Well, I put these three integrals together for discussion because they're just same integrand function. Okay, so I call this one I1. This one is I2, I3. If we find the antiderivative of e to the cosine x, and we can find these three definite integrals. Now, to find this antiderivative of e to the cosine x, it's not easy. It's not easy to find this indefinite integral. But we know that the e to the cosine, e to something, the antiderivative must be contain e to something. It's just a matter of a function times e to the cosine x. That is the antiderivative of e to the cosine x. Now, just a matter of finding f of x. Finding f of x is not easy. It's not that easy to find. Now, how about this? Let's take the derivative of the right-hand side. This will be f prime of x times e to the cosine x plus this derivative times f of x, right? Is equal to minus sine x e to the cosine x times f of x is equal to e to the cosine x. That's obvious. This derivative with respect to x is equal to this. And we cancel that, so we have a f prime of x minus sine x f of x is equal to 1. Now, to find the f of x, it means that we solve this differential equations, the first order. Well, to find f of x, by usual way, we are using the integrating factor, right? So if you were using that method, then we're going back to this equation. We go back to this. That means we're going back to finding into the indefinite integral. So it's not useful by using regular way. So we're using some other way to find f of x. So what is that? Well, I'm using approximation. Well, we know that when x equals to 0, f prime of 0 is equal to 1, right? Because this is equal to 0. F prime of pi, this is 0. It's also equal to 1. From these two, I guess, I just assume that f of x prime, the derivative of f of x is equal to x times x minus pi and the plus 1. No, plus 1, yeah, it's correct. But when x equals 0, this is true. When x equals to pi is true. The only difference that it should be multiplied by a coefficient constant k. Okay. So this one is equal to k x squared minus k pi x plus 1. Then we can find the f of x by integrating this, right? So we get 3k x cubed minus half k pi x squared and plus this is x, right? And plus c. Okay, I assume this is my f of x. Well, I don't think f of x, this is a true f of x, but rather approximation. Okay? We're using this cubic polynomial to approximate for f of x. This sounds like a Simpson's rule. You know? Simpson's rule. Many times we're using parabola to replace a function. Just approximation. Approximation is better than we cannot do it. You know, it's not perfect, but it's good enough. Okay, good. Then what? Then we want to find a k and a c. For two unknowns, we must create two equations to find a k and a c. So how about that? We let x equal half pi, then we get one equation, right? Then this means we're using this one. F prime of half pi. F prime is this. This is f prime, right? This is f of x. So k times square minus k pi half pi plus 1. This is f prime of half pi minus this minus k over 24 pi q plus, right? Is that right? Q. Is this correct? Yes. Q plus k pi over 8. And this minus pi over 2 minus c is equal to 1. So we are using this equation by replacing this for f prime, this one replacing for f of x when x equals to half pi. So we get this. So that we simplify, we get c is equal to k over 12 pi q minus k over 4 pi square minus half pi. So find c. This is equation 1. And we need a second equation. Let x equal be pi over 6. We plug this one here, here, here. So we have an equation, right? So this is k pi over 6 square minus k pi over 6 over pi plus 1 and minus sine of pi over 6 is half multiplied by f of x. This is the f of x. Replace x by pi over 6 over 3 pi over 6 cubed minus k over 2 pi q over 6 squared plus pi over 6 plus c equal to 1. That is this equation when x equal to pi over 6, and f prime is this, f of x is that. Okay, lots of details, and the calculations too. From this equation, we can find c is equal to k pi cube over 81 minus 5k pi squared over 18 minus pi over 6. That is equation 2. Well, equation 1 is this, equation 2 is that. Then from equation 1 and equation 2, we can find a c and the x, phi and a c and a k. C is equal to negative 1.5216, and the k is approximately equal to 0.4231. Of course, there are lots of algebra to do, lots of arithmetics rather. I did my homework, so this is not just tedious calculations, not as important. The method, the way of doing it is important. And from C and K, then we can find f of x. And f of x is equal to, by plug C here, by plug K there, and we find f of x is equal to 0.1410 x cubed minus 0.6646. Okay, this is my f of x. As I said, this may not be true f of x, but it's a good approximation by using third degree polynomial to approximate the function f of x. Well, I think it's interesting. Now, to find this integral, I need a f of a half pi and f of 0, right? So once you have a function, find f of half pi is not difficult. Just press the calculator. Okay, so this is equal to 0.1410 pi over 3 q, right? Minus 0.6646 pi over 2 square plus pi over 2 minus 1.5216. This is approximately equal to, well, negative 1.0441. While I did my homework. Now, f of 0 is easy. F of 0 just be constant. This is equal to negative, right? Negative 1.5216. That's f of 0. Now, the I1 is 0.02 pi e to the cosine x dx is equal to f of x e to the cosine x from 0 to half pi. So this one is equal to half pi. Cosine half pi is 0, right? 0 is 1, therefore equal to times minus f of 0 times cosine 0 is 1 times e. So we have these. This one is negative 1.441. Multiply this, become plus 1.526 times e. So this one is approximately equal to 3.0921. Wow, it's a very good approximation. Very nice. I think it's a good. I think it's great. That's for I1. For I2, I2 is 0 to pi e to the cosine dx, right? Equal to f of x e to the cosine x from 0 to pi. So this one is equal to f of pi and times 1 over e, right? Because the cosine pi is negative 1. So 1 over e minus f of x, f of 0, and the cosine 0 is 1 times e. So we just need to find the f of a pi. Well, f of a pi, we just plug value of pi there. We find this one. This is equal to negative 0.5674. Well, f of 0 is already, we have f of 0 is this, right? So I2 is equal to negative 0.5674 plus 1.5216 times e. This divided by e, sorry. So this value is approximately equal to 3.9274. Wow, it's a very good approximation. That is for I2. I2 is this. Now I3 is a 0 to 2 pi e to the cosine x dx. Well, we know that the cosine curve, this is a cosine curve, right? This is pi, this is 2 pi. And from 0 to 2 pi, so from here to here. As we know that this curve, this part is equal to this part. See, this part is this part. So it becomes that this one is a same as from negative pi to 0 and from 0 to pi, right? From 0 to pi. Yeah. So this way is more or less like this. More like this. Since this function is an even function, therefore this one you're going to twice the 0 to pi, right? Cosine x dx. So this is an even function, therefore we just double it. So we just double this value, which is equal to 7.8548. So this is my I3. So we find these three values, approximation. Huh? This is approximately 3. This is approximately to 4. This is approximate to 8. Well, it's a very good method.